Okay, we're going to get started. I'm sure some more people will be joining us shortly, but good afternoon, everybody. This is a webinar on best practices to safely restart your domestic hot water system. So I am the presenter today. My name is Hank Lenzen. I'm the Armstrong Technical Manager for Institutional Markets. And I am a former plumber, retired, and I was a plumbing inspector with the city of Chicago, and in the state of Illinois, I was a certified plumbing inspector. I work the markets now with the rep agencies and concentrate on the institutional markets. So for today, it's going to be a little less than 1 hour. We're leaving some time at the end for a Q&A, and all the participants will be muted. You can submit questions in the Q&A section during the presentation at any time. Answer your questions at the end of the presentation if you don't mind. The session is being recorded and will be emailed to you within the next 24 hours. I'll also be located, it will be located on the YouTube channel. We recommend closing any of your background apps. Browsers may impact your streaming quality. So with that, I'd like to make a couple of opening statements. Basically, right now, we're looking at what's happening because you've had stay-at-home orders. You know, they force buildings to close or operate at low capacity. The water systems have been compromised to some degree. They're designed to operate and flow water into a building on a regular basis. So establishing a proper plan to address the stagnated water system and the risks of that is something that we want to talk about. We want to pay attention to your cold water as well, but we're going to be really concentrating on the hot water side of the system. All right. Basically, what we're looking at is when you're reopening a building, you're commissioning or recommissioning the building. If it's been closed, or even if it has been at a lower than normal occupancy, it's very important that you look at this. Now, what we've got is you've got to have a plan. All right, so if you currently have a Legionella risk plan in place, you're ahead of the curve. So if you don't have a plan in place, now is a good time to create a plan to avoid any of the unexpected issues. So the interesting thing about that, I introduced myself as a plumber. I think the meaning of the plumber's creed and our motto of the plumber protects the health of the nation means a lot more to me right now as it does to a lot of other people. And you should have a plan for your hot water system to comply with ASHRAE, at least standard 188. You know, there have been a lot of code and health offerings related to opening a building from health organizations such as CDC, any municipal health departments, state to state. Things have been a lot of information coming out, and there's nothing that's exactly the same. So what we would recommend to everybody is we would recommend you to contact an engineering firm that you work with, a contractor you work with, or a building water engineering consultant that specializes in water management. And one of the first things you really need to do is determine the quality of the water and verify that the water meets the standard requirements to ensure a proper water supply to your building. Now that's very important, so you don't know if the building has been occupied, minimally occupied, not occupied at all. What about the area where the building was around? So it could be really a little bit more lengthy depending on the area that you're in. So that being said, what do you have with a safe domestic hot water system? So mitigating the risks of Legionella, which has been a big topic in recent years, as most of you probably know, in your domestic hot water system. There's been about 10,000 cases reported that have been positive Legionella tests. And as they continue to increase the opening of buildings and begin to get back into society here or run at full capacity, you're going to run into some problems unless you open your building properly. Now, people have not been paying much attention to their water plans over the years. Some people say they've got them. The healthcare systems have really stepped up. They've done quite a bit. And most of the hospitals and the VAs that I deal with are all in having a plan. They're all on board. But some of the private buildings, some of the hotels, some of the other buildings, they don't always have that. So what you got is you got current recommendations from the CDC, and there's been some ups and downs with that. They didn't quite put out the correct temperatures in their first go around. I think they've corrected that. But there's also individual state recommendations that are all over the board. They've got different recommendations depending on where you're at. They're general guidelines, and some of them are requirements and scope depending on your code agency or your state. So we're talking about up in North America at this point, but you can go to your state Department of Health or the federal agencies that are there. They don't have everything that you want to know all spelled out for you. Some of it is rather lengthy in scope, but you've got to sort through some of this. But what we're going to try to do today is kind of sort through just looking at the domestic hot water system. So we're going to look at high temperature disinfection. We're going to go over specific considerations to help you meet the guidelines that are being set out there. But first of all, what I want to do is a boots on the ground kind of thing. As a plumber, I want to evaluate your current system, right? So during your shutdown or lack of use in your system, all right, there could be a buildup of sediment and debris at some point, in addition to the pathogens or anything, the biofilm that builds up. And what I'm saying, and they don't really clue this in every report or every recommendation or restart action item from a state health department or the federals, find, remove, clean all your strainers, all your filters in the system, because that's where a lot of the sediment goes, especially if you have a mechanical room at the lower level. Of course, different sized buildings require different reactions. So water pressures, people don't think about this, but water pressure should be relatively equal between your hot, your cold, and your return system. Hopefully you have pressure gauges that would be a good indicator if your system's running properly with steady pressures. If you have inadequate pressures, that could be something in a strainer or a filter that is causing a backup, and it should be addressed before you go open live. In balancing your system, it should be as optimal as possible. So if you're going to do a high temp disinfection on the hot water side, it should allow for the proper disinfection for every zone that you go into. So when you're verifying your system, you also want to verify your recirc pumps are in good working order, right? Are they running? Are they in continuous mode? They have to be in continuous recirculation mode. This is something that I've run into quite a bit. I know that, for instance, in the state of Indiana, they're still looking at from a code standpoint on a new building. They want the engineers to always sign off that you're putting a timer or an aquastat on your pump. They have to do that to get the permit. And then as things move on, people don't really use them or they disconnect them. And so it's energy or safety the bigger factor, and in our case, we think safety is the biggest factor, especially in today's age. So if you're looking at a current hot water system, you need to be, for disinfection temperature, 158.6 degrees. We usually say 158, but it's 158.6 degrees. So we're talking about it. Legionella growth range is 68 to 122 degrees. That's a growth range. At 122, it survives, it doesn't multiply. Then you look at about 140, it dies within 32 minutes. And then at 151, it dies at 2 minutes. So the disinfection range, you want to get to 158. Now I want to talk about this because you've got to check your own water heater system, depending on if it's gas, steam, or whatever, boiler water. Water heaters should be set at, say, 165 degrees in order to compensate for any loss in temperature or to ensure that you're disinfecting the entire system. Because what you want to do is you want to bring back that 158.6 on your return. So if you calculate and you know your temperature loss, for instance, some people now currently have turned their building down if they were unoccupied to the lowest temperature possible to conserve energy. Well, now they've got to go back in and they've got to get their temperatures up and set. Right now, the recommended temperatures on hot water systems for running temperatures are 140. But the 165 is a generic number that I use. It's 10 degrees, 7 degrees or 6.4 degrees above what you need there. So what you need to do to calculate your temperature loss is if you have your water heater above that and you bring back your return, you want to see that return at that 158 or 158.6. So an example is if you were sending out, before you even started disinfection, if you were sending out 125 degrees and your system was returning to your mixing valve with your water heater at 112, you'd have an 8-degree loss. So what you want to do is you want to make up that 8-degree loss, add that to the 158, and you'll come up with your number. So that's one way of calculating what you need to do for your temperature loss. So with that being said, when you look at continuous recirculation, I've got a graph here, and it shows you your water heater should be set at 140. Now, in this example, we've got the pump on, and we've got a building set point of 130. It's showing 131 coming back, 135, 136. It jumps around a little bit. 140 coming back. But we ought to take that aquastat off. We don't want that aquastat to be on. We want to keep that pump going, get it going continuous at this point. So we want to bring back as close as we can. We only have a 1-degree loss in this particular installation here. So there's no standard of care, no water safety plan, and not a single Legionella consultant that doesn't strongly discourage stagnant water. Stagnant water is what our problem is right now, especially with these buildings being shut down or closed. All right. So you want to keep them pumps on. You want to be excluded from these energy codes in this case because the safety is that much more important. We want it water circulating through the water heater to prevent stratification. You want to circulate it as close to the fixture as possible. Every fixture opening as possible. You cannot control the temperature of the water that is continually recirculating. You might get a loss. You might stay pretty close to the same. Rule of thumb I use on a new building, I usually see a 3 to 5 degree temperature loss. And some of the older buildings, I see an average of 7 to 10 degree temperature loss. But if your central mixing valve requires an aquastat at the pump to help cool the system, then you're not pulling up with the right one. You got to get this continuous recirculation. So that being the case, during periods of no demand, right, you've got it right here. You're sending out 140 out of your water heater to your mixing valve. You're putting out 130 degrees. You can see it going to all the fixtures. You're getting as close as you possibly can. Your GPMs in the system are very important. But as you see in this example, we're bringing back 124. So in ASHRAE 188, and I know they've got a 12-2000 now that I haven't looked at 100% and studied, but I do believe that the 124 bringing back is something they're recommending. So now, given that case, of course, the rules and the codes for point of use really come into play. You'll notice that we have faucets here that are on this picture here, and they actually would have a point of use that can bring it down in temperature to meet maybe the 110 or the 115 at the point of use. But we really do want to have something that's right there. As far as what we got going up here, if you've got a pre-piped digital mixing valve like we have here, we're going out at the 140 degrees. That's a very important number. That's very important that we make that work out. So as we move along with the 124, what you've got to do is you've got to remember that you can go into a multi-zone, which makes it a little bit easier. So when you're doing a disinfection, we're sending out 160 degrees, right? The advantage of a zone system is you can do it by a zone if you have it. And the disadvantage is that if you don't have a zone, you've got to try to do a whole building. If it's occupied, then you have a problem with trying to protect the people that are using the fixtures. An example for us in our disinfection mode, I've done a lot of training with some of the VAs in the area, and they have to do it on a monthly basis. And it's very important to do that for them. They'll do a cold water flush and they do a hot water flush. So we're talking about this, so you got to verify if you're going to be doing something. You're going to have to verify. You're going to have to verify what your point of use and your fixtures can make this work. Now I'm trying to see if everybody's got audio or not at this point. Somebody is saying they don't have audio, but there will be a copy available after the presentation, and hopefully everybody's got audio at this point. We're going to back up. So some faucets and point of use mixing valves, when you're talking about this, they don't have the proper maximum temperature that can handle a high temperature flush. So you have to verify what you personally have installed in your building. Verify what you have installed and if the fixture can handle the increase in temperature or disinfection. So that's very important. Now, point of use mixing valves, if you have those on there, you got to verify that you have a temperature limitation on the valve at all. And you may need to disconnect and bypass these valves to complete a proper flush. Now, I ran into an issue at one VA where they had a point of use mixing valve that was there, and that's where you sometimes learn from experience. They did not have the proper cartridge, and it was too low of a temperature setting. So they burned out all the cartridges and had to replace every one. Now, luckily, that was one of 8 buildings they were doing on a VA campus. So they were very lucky. They caught it early on the first building, but they were required to do a high temp disinfection at every building once per month. And they have to do that and make sure that it is very important that all of the end user locations are covered and they get it, they don't have any problems. So I was having a little bit of a problem here with the slide. If you give me a second, go back up. Bear with me. My apologies. Anyway, we're going back up. A little hiccup in the presentation there. So when you got shower valves, they have a maximum set point. They have limiters in there. So what we want to do is get into the nuts and bolts of the plumbing system. You know, you might have to adjust or open up shower valves in order to complete a high temp disinfection flush. You know, I was online the other day, and then I got on a phone call with a hotel system that's looking at reopening their building. And, you know, he had a couple of problems. He didn't know how to do it. Luckily, he was able to set the temperature high enough, but he had storage tanks. So it was going to take him a period of time of flushing the building as it was, just to get the storage tanks up to the right temperature in order to do a high temp flush through the building. So that was very important. But shower valves, point of use mixing valves, faucets, you've got to make sure your temperature settings do not exceed what the recommended for any of the cartridges within any of your fixtures. It's a little bit of work, but you've got to do it. So if you look at it, you're flushing your system at a high temp. You want to address stagnant water. So each fixture or each faucet location should be flushed. I use 20 minutes. There are different varying numbers, like at the high end, but if your water's not clear, you're showing any turbidity, you should flush it until it's clear, and at least another 10 minutes beyond when it's clear. So you have to make sure if you have a thermometer with you when you're flushing, you can verify that you're getting a temperature of 158 or 158.6 at each fixture being flushed, because otherwise you're not getting a proper flush. You want to go through the whole system. So only open and flush the number of faucets and fixtures you can generate. So what does that mean? How much, if you have a hotel, a 5-story hotel, or and you've got trying to run every bathroom shower, every sink, you're going to run out of hot water. So you have to do it in a section by section basis or a floor by floor basis. And you need to see how long it's going to take and what it's going to take you to put that in. So what we're talking about is you've got to generate enough hot water in those GPMs to make that work. That's just it. So when you're talking about testing is very important, especially right now. All right, there are different companies out there to do testing. There are kits I've run into now that there's companies that provide kits, and you can try to do your own. I would recommend that you try to do something with an engineer, a water management engineer, or a plumbing contractor, or a mechanical contractor, to work with them, somebody that might know your building, know what to do. Now, I'm going to say this. I've been doing this with Armstrong for the last 8 years, and I found that people are always worried about cost, and I get that. Cost means a lot, especially with everything going on. But safety has always been a number one priority, and it should be for everybody. But now even more so with the COVID-19 response that we've had. So, with hand washing, infection control, anything like that. Healthcare, like I said earlier, they do it quite a bit, and they're really on top of their programs. So if you don't have a program, try to get one in place. There are a lot of sites on the web you can Google, and there are a lot of people that do this. There are a lot of great people that have things, some universities that are doing things. So you want to basically, what you want to do is you want to get rid of the biofilm and any associated bacteria. You want to do Legionella. Now, some people recommend to test before, and some people want to mitigate and do what you can to make sure your system's in good order before you test. My recommendation, and the way we look at it sometimes, what I've seen in the field, is that you really should make sure your system is up and running properly. Do you have any dead legs? Dead legs are piping that aren't being used. Here's a good example of a dead leg. I had a hospital that was a 4-story hospital. They didn't use the 4th story for a number of years. So nobody was going up there to flush. And even though it recirculated inside at the main room, you had 20 feet of water that just sat stagnant, and that caused the problem. So they ended up having to do a lot of things. So make sure that you look at what the plan might be. You're going to have to spend some time. You're going to have to spend a little bit of money to get it done the right way. And then you definitely want to do a test to make sure by an approved testing agency, engineering consulting firm, or something of that nature that's going to make it work. Can you? Yes, you can go out and get a self-test. You can do it all yourself, and that's all on you. You can make that happen. But get the test, that's definitely, right? So what we're doing, I got to get that off. Setting. So when we get it up there, the brain, let me get it up here again on my apologies. Not real good at the settings. So as we're moving along, the brain, which is what Armstrong has, we are working with the brain, which is a digital master mixing valve. All right, we offer a disinfection mode, right? So in the disinfection mode itself, again, my apologies for making this happen. So as I'm moving along here, with digital mixing valves have been out for quite a while now, and they've taken over from the mechanical mixing valves. So when you make this happen, the brain has made it a lot easier. Me as a mechanical contractor or a plumbing contractor, I've tried to set mechanical mixing valves for a number of years, and it takes a lot of work, and they're not always real accurate. The digital age is upon us. There's the brain. There are others that are out there. We feel the brain is the best, the easiest to work with. But basically, it takes the hot water, delivered from your domestic water heater, and it mixes it, sends it to your building with a system at the proper steady temperature you select. And it does that on a regular basis and for disinfection. Now, in the disinfection mode, you could set a timer. And what does that do? In the disinfection mode, how long will it take you to do a section or an area? And do you want to do it? You could set it for a number of minutes. You could set it for hours. A good example of that is one of the VAs I have when I originally started, when they were doing it with a mechanical mixing valve, it was taking 7 or 8 guys, I believe, 8 hours to complete a couple of floors. Now they do it with 3 people and it takes them 2 hours, a big savings. Now the cost of a digital mixing valve over a mechanical is big, but they're a true believer now. And what happens is when you get into the proper amount of time, you can get in there and you know how long it takes you to do it. So for instance, on a floor, if it takes you 20 minutes to go from one end of the floor to the other to open the faucets, you want to get them for 20 minutes also. So it's going to take you a little bit of time to get a floor done. So you need to determine that based on the size of your building, where it's going. So what it does is you also have a cool down mode, and that you have an abort button also. So without a digital mixing valve like the brain, it'll take more time and effort to complete disinfection. We feel that this is really a great way to do it if you're going to do a high temp disinfection. So if you currently have a mechanical mixing valve, you might find that tuning a specific temperature and keeping that temperature to complete disinfection will make it a lot more time and manpower improbable at this point. That's what it is. So when you're talking about on your domestic system, you have one, make sure that you work it and you stay diligent on your plan. You have to do that. If you don't have one, maybe we can help you create it or you can find it. So as we're moving along with the brain in the disinfection mode, it's got a lot of different capabilities, and which includes, we call it Sage, and we have a Sage motion on this. And in the Sage, what we're doing is a cloud offering, but it also connects to your building automation system. Now, for years, the plumbing, as I know it, we never were on the building automation system. Your fans were on and make sure your air is moving, your humidity was on. You wanted to make sure things were moving, but they never paid attention to the domestic water. Domestic water is a very important safety conscious item that you really have to go with there. So it really needs to move along, and you've got to look at possibly putting it on a building automation system. And if you don't have your own system, we do have a Sage package. It's a cloud-based system that can help you. And what it does is it will keep track of what's going on. It can alert you to any problems in your domestic water system. It can track your temperatures. You can change your temperatures. But as far as the disinfection mode, you want to do that hands-on at the facility because you don't want to have any problems at all. It's where you want to go with that. So as we're moving along, we're going to go a few more minutes. So make sure you work that plan. You can get that with the Sage. Armstrong has come up, we're going to come up with some questions and answers that are coming up here. But the most crucial thing, again, is safe. Safe is really good. Low and undetected levels of disinfectant in your water or your chlorine could be happening right now. So maybe you need to go to your municipal supplier of water and make sure that they are supplying you with the proper amount. You can do a simple chlorine test at the intake at your building. You got to make sure you've got something in there that's going to work. So if you do a disinfection, whether it's a cold water or hot water, you do want to have levels of chlorine or in your water to make it work properly. Because, you might have right now higher levels than normal of any copper, lead, or bacteria. You want to make sure that it's there. So what you want to do is, this is not just for healthcare. This is for every building. I believe that hospitality and hotels are extremely important in this regard. The casinos are opening up in Vegas. We know those hotels got to be safe. So check the levels of chemicals. You know what you did to shut down your building. So look at what you might have to do to get it back up and running, So there are a lot of changes and a lot of changes over the years with all of this, and it continues to change on a regular basis. Like I've said, I've got article upon article, and I try to stay on top of things, whether it's from the EPA, who has maintaining and restoring water quality in buildings. They have something that's going on. So in that regard, we've also got some other things that are coming up and newly released. Armstrong, we've just released the high-efficiency gas-fired condensing water heaters. We call them the AVH. It's digital controlled package, complete pre-pipe package solution. We do anything modular heaters up to 599,000 BTUs. It's a rack system up to 4 million BTUs on the rack system. And this also can come with the SAGE monitoring system and the documentation. Also, what's coming up, which is really exciting to me, being an old plumber, you know, I remember when these first came out, anything to do with electronics, from a union standpoint in Chicago, we always were fighting over who was going to get to work. It was water going to the faucet, but now it was electric. So whose work is it, the electricians or the plumbers? Well, that's kind of years ago, and they've come out. And hands-free is very important, especially in this day and age with the COVID-19 that came around. Hospitals have had it for a long time. Some public bathrooms have had it. I'm real excited that we're going to be representing the brand digital point-of-use faucet. It's a little bit more than what you've got right now that's out there. It's not only a non-touch, right? It's programmable, and you can get a duty flush out of it. In other words, it'll flush itself. You can set it for a number of hours where you don't get stagnant water on a regular basis. And if somebody doesn't use it during a certain period of time, it will automatically flush itself. You can do a thermal disinfection with these, right? Everything's got brass in there. There's no plastics, brass valve engine, the 4 copper outlets, no plastics there, flow insert. You can take that out. That's your aerator. You can get that out. It's got an integral data log. You can see what's going on there, and you can use it on your network, and you can make that happen. So with that, that's coming out. That's something really exciting, something to look forward to for me, but it's very important that everybody looks at this point of use, built-in temperature control right there. It's going to spend a little bit more time, a little bit more money on the front end, but you avoid any problems in the long run. I've had a building that was a hospital that had Legionella. They ended up having to put filters in every faucet until they mitigated the whole problem within the facility. And that's hundreds of thousands of dollars. So it can't get to that. People don't want to spend the money up front. They don't want to spend the money on their buildings. I get that. But if you're looking for the state of the art and you're really looking to get into a real safe environment to offer your customers, your clients, your tenants, this is something we got to look at. So we also have, which Eric Knauf, an engineer out of Florida, has helped us with a pipe up manual. It's a hot water piping design manual that can help with some of this, with your disinfection mode and some things that are happening in the industry. Proven recommendations on hot water design, methodologies, velocities, system temperatures, pipe routing considerations, everything's in there. Detail the process of calculating system heat loss, right? Discussing sizing, providing information on supply and recirc and multi-pressure zone systems, which is a big deal. Details for the need for mixing valves and codes and standards associated with them. So you can also contact us to schedule a pipe up webinar, which most of our technical managers do around the country with your firm, whether you're an engineering firm, an end user, a contractor. It's a pretty useful tool and something to really look forward to. So another thing that's really, really important right now, we talked about hot water and some of the recommendations there. Next Thursday, we're going to be doing an upcoming webinar on indoor air quality, which, as people are hearing with the COVID-19, is very, very important. So you want to learn about that on indoor air quality and discuss the lineage between controlled humidity and virus transmission, respirator health. So this kind of falls into the same realm of where we're at with safe hot water. And as we're doing that, a registration link will be available for that. And then a registration link along with the recording of this presentation will be emailed to all of you within 24 hours. I know we're probably finishing up a little bit quicker than I originally thought, but what I want to tell you is a good source is not only Armstrong and our people that have a lot of experience, but you also have the web and some of the engineering firms and contractors. Keep them in mind for what's going on. So at this point, what we're going to look at is we're going to look at some of the questions and answers and to see if I've got anything at this particular point to see what we've got going on. Let's see. So any other questions we got here? So the chat. We got any other questions about it? Temperatures? Again, 100. Somebody had a question on temperatures, and that had to do with anything that you are putting out. That's a good one. Somebody was asking, you know, hey, they're putting out 120 degrees. Well, that I see that a lot, and that's because they don't have point of use mixing valves. And the really important thing here is for people to realize that what you've got is if you don't have point of use mixing valves, you have to put it out at a lower temperature so you don't scald somebody to meet another code of say 110 or 115. And I get that. Most tub and shower valves are thermostatically or pressure balance controlled nowadays, but it's the laboratories where they have the problem. But the growth range, again, is 68 to 122 degrees. So you really want to get that up. Definitely get your water heater up above 140. I actually have some people that are above 160 on their water heaters now, and that's really up to you. Some people are getting away from storage tanks. Other people are going more instantaneous, as long as you can keep up with what your flow is. So 140 on the water heater, and try to put out and bring back 124 is a tough road, but you've got to try to do that. The brain would help you do that and make that work. Let's see if we've got, can we comment? I'm going to see the other one there. Let's see another comment. So, bear with me, I'm going there. Can you comment on the testing? On the testing for free residual oxidant. I cannot comment on the testing at all myself, and that's a water management person, and none of us could do. You cannot do it from our standpoint. We cannot do that. That's not in our aisle. But you can try to do it yourself. There are some companies out there that you can look up that have the testing kits and can walk you through it. But my recommendation would be to go through an engineering firm or a contractor to do that on the recommissioning. And the next question is, any recommendation on how long to circulate the high water temp? Just had a customer recirculate 150 for 24 hours. Wow. I don't know if you've got to do it that long. You must have a small building, because boy, if you're putting that 150 degree water and flushing it every place, God bless you. You know, 150 doesn't quite meet the disinfection range. It's nice that you're flushing. If you're dumping, flushing and dumping meaning getting it out there, that's it. What we're talking about is if you go to every point of use and you flush at every point of use within your building, you're hopefully getting rid of all of the legs within your system. So what you want to do is you want to know how many, and that's part of your plan, how many openings do you have, where are they located? And then you want to do is you want to be able to flush there. So at that flushing point, how long is it going to take you times for each flushing point and go times how many units? Now, you can open multiple at a time, like we talked about earlier. There was a floor at a time. Say you got 30 rooms or 30 hotel rooms on a floor. What you're going to do is you say, all right, I'm going to do those 30 rooms. I'm going to do those for 20 minutes. So that might take you an hour to do that floor. So you have to calculate that out. So just by recirculating water doesn't mean you're getting all the legs and all the faucet openings and all the spouts, and you need to really get to that point where you're flushing that out. So then after you're all done, you can check. Whoever did that at 150 for 24 hours, you should get a test and see what it did to your system at some of your openings and see how that might have worked for you. So that was that one. I don't know if anybody else had something on any of the changes or the questions at this point. But you can always send them in. My information is up there. If you don't have a question right at the moment, my contact information is there along with my cell number. You can either text me or you can send me an email message and you can make that work. What else do we have here? And the question. So recommended protection for the person performing the flushing of the faucets. That's a good one. So what we're talking about there is the entire building needs to be done. Your protection should always be proper PPE, especially when we're talking about the possibility that when you're flushing, you might have some Legionella or some bacteria in those. You should always have a mask, a face shield, and you should have gloves, and you should make sure that you're protected properly when you're doing that. So anytime you get it, you don't get those sprays. They keep talking about sprays when they're going up there. So about chlorination, absolutely. There are companies out there, contractors out there that can go in and chlorinate the entire building. You need to verify that with the proper people that are going to do that properly. You can do it. There are different recommendations on parts per million. The problem you run into with chlorination, which is always on a startup or a commissioning or a restart, whether it's a new building or an old building, some of the equipment manufacturers will void your warranty on your equipment if you go too high for too long of a period of time. So when you're talking about chlorination, you're talking about, I've seen it for a 24-hour period. It could be 100 parts per million. I've seen somebody put in 50 parts per million. But you've got to make sure that that gets flushed and it gets done properly. So hire the right person to do that. So yeah, chlorination is also a complete something that you want to do there. So we've got that protection, and this has been recorded and it's available for viewing later at this point. So I don't think I see any other questions at this point, and I wanted to thank you for your time, and I hope that this was informative and that you'll join us again for some of these other great opportunities that are coming up in products. So somebody else just asked one more question here. How long does a building need to be down before they're at risk? You know, it really varies. It depends on what's going on with your system. What they're saying is that even a municipal system can lose the chlorine content if it's stagnant long enough. So if you've got a low-use building and you've only had a couple of tenants and it's a big building, you might have stagnant water and it's a risk for them people to be in the building. So it really depends on the size of your building and everything else. And anybody that's had any closure whatsoever should really consider checking your system thoroughly, upgrading, cleaning strainers, cleaning out everything you could, removing aerators, doing a flush of your system, both a cold temp and a hot temp. On the cold side, being a plumber, what I would do too, you've got a lot of traps that might have dried out if you're not there a long time. Your toilets need to be flushed. You get your cold water going, and the hot water, everything's got to be flushed. So somebody asked any thoughts on drain, why not just drain down the water system on a building during a shutdown? Well, two things with that. You don't want to completely drain it out. You can flush it and do a wash down. Like, for instance, you'll see in a municipal application, you'll see a hydrant flush where they want to work the mains out, the water mains that are in a city or a village or a town. They'll open up the water mains and flush them into the street to get a flush to get something out of the system, or if they have a break in a water main. It's the same thing in your building. You don't want to really drain it completely. You want to push water through it that has some chlorine in it, can maybe on the hot water do it at the high temp, and you want to push it out. You can drain it out. For instance, on our slide, somebody just asked that, and on our slide we showed earlier, on your return coming back, you can bring that water and you can run that to drain, and that will help you start getting rid of what you had in your system. But to completely drain it out, what that does is that pulls a lot of debris and possibly contamination from the sidewalls of the piping, and then starts clogging strainers and filters and everything else. So you want to keep the pressures up. If you're out there, you want to keep the pressures up. You want to keep it going right through it. So as far as the amount of time, it really depends on your building, But anybody that's been down for any amount of time at this point, very important. But do not completely drain down your building and then try to fill it back up. It's not a good idea, not good for your system. It'll take you more time and more effort. So the flushing is the very good way to do it. Do it the proper way. Make sure you get the right people, right, to make it happen. So another question was, what would you recommend also for hot water temp? Well, right now, again, there are different thought processes out there, but if you look at it, you're looking at the recommendations on hot water temperatures. When you restart, you make sure that your hot water generation is at least at 140 degrees minimum. That's what the current recommendations are coming, right? And then what you want to do is the temperature. They're starting to recommend temperatures to come back at about 124 degrees. Again, remember the growth range for Legionella is up to 122 degrees. It causes problems without point of use mixing valves. And I think that some people are going to have to bite the bullet here in the near future and get into the point of use or get into the better faucets like we're offering with the Rata faucet. You're going to have to do something. I know a lot of people don't like the point of use mixing valves that are under the sinks. A lot of the faucets are ASSE certified, and we've got to make sure that you've got that at the point of use. But you need to get the returns. Some of the older buildings are tough, and you've got returns in a hallway with 20 and 25 feet of dead leg unless you're flushing at the fixture. So you got to make sure that you get everything flushed out. But the bottom line is you should be putting out a higher temperature and constantly recirculation. But, below 68 degree, Legionella survives, but they're dormant, So the cold water, can be also used in the flushing process. You could do a cold and then a hot. And I've had a couple of VAs here locally by me recently that are doing both cold water and hot water flushes. Pretty interesting that that's happening right now, but it is all over the board. But you want to do the testing. You want to make sure your temperatures are running, that you can handle the right temperature. Minimum of 140 at your hot water generation. All right. So if you're having problems in your area, that's the other thing to talk about. If you're in an area where maybe the water main's needed, you've got to get a hold of your local municipality and see if they're going to be doing a flush. You could get a kit to check your chlorine levels and test for yourself, or you can hire somebody up to do that. So anything to do with equipment, whether it's in the hot water system or the cold water system in your building, you've got to check all of your equipment. You've got to check your backflow preventers, your check valves. You've got to look at it. Look at getting the program in place, monitoring your system, adding domestic water to monitoring in your system, and that would make it good. Somebody's saying, well, do thermostat mixing valves have the ability to do a thermal disinfection cycle? Well, they might, but they wouldn't be consistent. I think some of them you can open up wide, some of them you have a bypass on. You really have to look at the individual one. I just know in my experience, holding a temperature is very difficult. When you have a digital mixing valve like the Brain, it really holds the temperature well. We get it up to temperature rather quick. You can feed 200 degrees to the hot side and mix it with some cold water and get it out at 165 degrees. As soon as you bring it back at 158, you start your flush. It will keep consistent. While you're monitoring the disinfection at the valve, because you want to be able to abort it at any time, you're looking at the temperatures. If you start losing temperature on what you're sending out, you're opening up too many openings, or too many faucets, too many fixtures. So you got to get to know your building. You got to get to know what your GPMs are available from your hot water system to be able to feed the mixing valve. But a mechanical mixing valve is very tough to use during that. And then another question was, what agencies are regulatory bodies that we're getting our temp spec? Well, you know, there again, it's getting all over the place, but right now there's been some engineering firms that I've been working with that we get them. ASHRAE is coming up with the temperatures. The 12-2000 is out now. There are different state health departments that are putting out different temperatures that are kind of all over the board. The codes are all over the board. You know, it's if you do a cursory review for yourself, like a lot of people have done, you know, it is really all over the board. But 140 is the temperature range, and ASHRAE is coming out with that. You can look out for the ASHRAE, and that's where the return temperatures are coming. But everybody, somebody's saying, what regulatory bodies are you getting your temp spec from? It is all over the board. I'm not gonna, I can't say that. I like to follow ASHRAE. I like to follow local codes, but they don't always coexist. The National Plumbing Code should become more compliant across the nation so we quit having this problem. I think people are working towards that because every municipality can have its code. You could have a city and a state to have a different code. You could have a town next to another town to have a different code. But these temperatures are going to become something that is not only a hot topic, you're going to find that they're going to come to an agreement pretty quick with what's happened with the COVID-19 at this point to avoid Legionella. So, yeah, the regulatory bodies on the temp spec is really, I would go with ASHRAE. The American Society of Plumbing Engineers have been a part of that. ASSE, American Society of Sanitary Engineers, it's ASSE, they're all part of this process. And they have some engineering firms that are involved with this. So ASPE, it's plumbing engineers, American Society of Plumbing Engineers, they're right on top of this. They look at the higher temperatures, they can look at the buildings. So if you have somebody that is a local engineer that you use, please make that call. You can talk to them. You have a regular contractor you use that you can rely on. You can talk to them about it. But codes will differ from what ASHRAE says right now sometimes, so you really need to check all the boxes. With that, I don't think there are any other questions, and I really want to thank everybody. I think there was anything to do with, let's see, where we get? There was one about pricing. As far as the pricing, I'm a technical guy, and we're going to follow up with that on the pricing. If you left a message there, we'll get somebody to follow up. But if you need us, we're here for you. If contact Armstrong, one of your technical managers like myself, we're all across the country. I really appreciate this time to share with you a boots on the ground type of thing, because quite frankly, there are a lot of information being put out there right now. I'm trying to compile it myself. I'm trying to give you some realistic views, boots on the ground, hands-on. What do you have to do with your facility? What do you need to look for? The number one thing that I want to say about this is you definitely want to get a plan in place. You definitely want to start monitoring your hot water system, and you definitely want to check your equipment. And you want to make sure that you monitor and you maintain your system with your plan. So we thank you very much and look forward to working with you again. At this point, that would be the end of our presentation. Thank you very much.